Benedict said a few things about me. I have an engineering background, and I've been working on semantics and interoperability for a number of years. And I think Benedict is right. I'm not going to talk very much about the technical computer aspects of it, but I'm going to talk about the deeper semantics of the semantics. So I come from the National Technical University of Athens, but I'm also with the hat of the Agile, the Association of Geographic Information Laboratories in Europe. And my experience comes also from the work we've been doing at the Ontology research group at the KGiA. But let's leave from this boring stuff and let's get into the context of the talk. So in the beginning of the 80s, the big question, especially not known to the young ones, was what is special about spatial? And this question was asked in two ways. One way was negative. That was, what is so special about spatial information? Especially the computer science at the time thought that spatial information was like any other type of information, any other attribute. So if you said that a particular piece of land had the land use of, it's a vineyard, that was the same thing as any other spatial property of that entity. So that was the negative side of it, but the positive side of it led to what is known as a geographic information science in the beginning of the 90s, and a few years later on to a big industry, an industry which has a lot of economic, societal, and other impact in an era where the digital maps have supported more than 1 trillion in sales for businesses, and many other numbers that you can find in many studies like this recent one by Google or other ones. But more importantly for us, this led to a renaissance for geography and mapping. It is a big comeback with an entirely new role. So today I would say that almost everything is spatial, and I'm not very sure about this almost. And we know that maps are everywhere. And we all know that in order to follow the spread of the pandemic, we use a lot of maps. Like people became more familiar with maps because of this single cause. And many apps like the ones we saw earlier by some of the speakers on the follow, on the tracing of the pandemic, but many other applications today use maps. And some are peculiar, some touch upon private issues, but anyways, we know that we live in a spatial era. And this era is characterized by massive amounts of resources, the resources that provide knowledge about places, events, phenomena, geospatial concepts, and they come as unstructured or semi-structured form, and they use natural language. So it's very important to have ways of supporting the semantic annotation and search. So in this spatial era, we do not only have positive things, we have also negative things. First of all, we have lots of data, but we have an uncertain meaning. We're not very sure what this data means. And we have also new cartographers who produce questionable content. Sometimes they produce this questionable content by ignorance, sometimes by, intentionally. But it's important to see that. Also, spatial knowledge relates to another important issue, that of spatial literacy. We cannot talk about spatial knowledge without thinking in a spatial way. And we have also difference between the views of the world, difference from the experts and difference from the non-experts. The non-experts usually use their common sense. But if we look into this common sense, we realize that it's not that common. We think we share things and we understand things in the same way, but that's not the case. And we have actually conflicting versions of the truth. And that reminds me of this Italian drama by Luigi Pirandello, which said, "It is so if you think so." So we have many different versions of the truth in the world. So we actually live in an individual constructed Truman realities. And as the internet, we know very well that the internet does not show to all of us the same truth. The thing that the internet serves us is what actually not really what is true or what is valid, but what would trigger us to have more interaction. So interaction is the key issue for the internet to provide us the reality. And this leads us to another issue, that of, as we have fake information, that of fake maps. And this case of having good maps or terrible maps or fake maps comes from the realization that the authoritative character of maps is that strong and easily believed that it can be easily exploited to convey fake information. And that was realized many years ago by Marc Monmonier in his in his very famous book, How to Lie with Maps. So in order to understand what needs to be done in this new era, I'm going to touch upon three things: the semantics, the geospatial thinking, and the new cartographies. But what is actually spatial thinking? To some of you that may not really know, you know that not all of us are good with maps. So there is a big issue here about lack of map literacy. We also know that some of us have trouble finding our way, especially in complex situations like big malls or other places in the countryside. There are many studies about the time we all lose, or some of us lose from our life, looking for our car, where we have parked our car. And we also know that some of us have difficulty interpreting diagrams, follow manuals in order to assemble some pieces of furniture. So all these issues, also like planning our daily route to visit certain places during the day in an efficient way, similar to the traveling salesman problem, all these tasks rely on a mental skill called spatial or geospatial thinking. And the spatial relations that include these abilities are many. Golitz and Stimson in 1997 mentioned some of them, like recognize spatial distributions and spatial patterns, connect locations, associate and correlate spatially distributed phenomena, and so on and so forth. It's not that important today to go through these, but what is important to know is that spatial skills can be improved. We're not doomed if we're not very good spatially. We can have it improved. So training matters, and we can improve our cognitive spatial ability. And once we do it, these abilities are durable. This is also important. And there's a relationship of performance on tests on spatial skills and the choice of careers. So this is a short introduction of what spatial thinking is all about. But in order to realize and build on this spatial thinking and the concepts involved, we need to talk about semantics. And semantics, meaning and knowledge are closely related. And by semantics, we're not talking about the thematic information, the attribute information in our databases. We're talking about what do we really mean with the term, with the concepts we use. So we're also interested in the importance of formalizing meaning. We're very much interested in the difference between experts and common sense views. We're very much interested in the semantic interoperability issue, the role of essential properties in reaching meaning, how we deal with scale and detail, and also how we elicitate spatial knowledge from different sources such as text. And all these issues more or less touch upon four processes. The semantic information extraction, ontology, enrichment, and population, semantic search and knowledge discovery, and semantic analysis. Let's look into the semantic information extraction. Here we need automatic processing of unstructured or semi-structured resources and the identification of relevant information. And by this, we actually mean four things: the entities, concepts, relations, and topics. Let's see an example here. Let's see if we have a question like, is sea level rising? And we try to find a source of information about this, and we see this one coming from the US National Ocean Service. So for us, it's very important to take this piece of text and be able to arrive to meaning out of this. And in order to do this, we have to derive, find out what are the concepts, what are the instances, the entities, in other words, the relationships also, which are very important, and also the location where things happen. Another example here is the piece of text that we need to process in order to arrive to spatial concepts, spatial entities, spatial relations, and instances of relations. So here we see that spatial concepts are atolls, coastal areas, islands, sea level rise, coastal erosion and flooding, low-lying countries and areas. The instances of relations are Maldives and are on islands and low-lying countries such as and the special entities is Maldives and Tuvalu. There are many available tools that help us to elicit this information from text. Some are more successful than others, are general tools, but what is important is that sometimes we need to use more advanced tools and more information in order to get the semantic information out of the text. And ontologies help us a lot in this aspect. And this is what I'm going to also talk about. So ontologies are used, as we all know, as means to formally describe domain knowledge and assist the extraction of predefined concepts and instances. But the quality of the information extraction depends heavily on the sophistication of the underlying ontology. But ontologies, like standards, as you know, there are many. As the bad thing about standards is that standards are, this joke that standards are very good. Everybody should, make one. And it's very important to use ontologies in order to enrich our information. And here I'm going to also talk about the semantic enrichment of user-generated scenarios with spatial concepts and entities. As an example, I used the GeoThink project, which was a project with a goal to enhance geospatial thinking skills in education, and actually use semantic pathways to build a spatial thinking society. So the important thing here was to get a lot of material produced by collaborative groups and come up with the semantic linkage of knowledge, so based on their correlation and relevance. And the test here was that We use a number of open educational resources, and in six languages we associated them with geographic entities, with ontologies, and we came up with a semantic network of over 300 spatial concepts. Also, the important thing was that it was associated with location, so we could support map-based search and visualization, but also semantic search and visualization. Now, of course, this goes through a number of well-known steps like linguistic preprocessing, extraction of geographic entities like Mediterranean, Europe, Greenwich, and also the concepts. We extract concepts like distance, and we find them in the ontology. And at the end, we arrive to an enriched case where we don't just have things connected together, but we know to what they're connected and what is this type of connection. And also, as I said, we associate all this information to location. So we know, for example, where a story takes place. The other important thing is the semantic search and knowledge discovery. So here we're not talking about keyword search, but we're talking about semantic-based search. And the important thing here is to use ontologies and semantics to find things that do not necessarily contain our keyword. For example, if we're looking for geological phenomena in the Mediterranean, it would ideally return resources including earthquakes in Ionian Islands, volcanic eruptions of Mount Vesuvius, and soil erosion in Spain. Although all these three resources do not explicitly mention the terms geological phenomena or Mediterranean. So it's important that to use ontologies and to support this type of semantic search, like here is the example I mentioned just earlier. Another important issue in ontology integration is that, as I said in the beginning, we think we understand the same thing by the term forest, river, lake, so on and so forth, but usually each discipline or each person understands things differently. So it's very important to have ways of associating, integrating ontologies, not really amalgamating them, not really forcing them as we do with the standards, but keeping them independent, but associating them so that we know a concept in one ontology, how it translates to a concept or more concepts, or a part of another concept in the other ontology. So we've developed ways of integrating ontologies, which of course is a big issue, as it was mentioned in the previous keynote. One of the, I would not say not the unsolvable problems, but not really the difficult problems, I would say. How we semantically integrate ontologies and databases. Another issue not really dealt with sufficiently is the way we deal with concepts and ontologies in different scales. So things do not mean the same thing at different scales. So here was an approach of how we integrate ontologies at different levels of detail. And this helps us know that if we deal at that level of detail, we should use another ontology that is associated to the more general ontology. So here you see, for example, that this is one of the difficult problems in cartography, the problem of generalization, and this is about model generalization, not really geometric generalization, of simplifying lines, points, and polygons. But of course, in order to do this, we need some datum information, some reference information. There have been some. Can you hear me? we need some datum information, some reference information, and there are different ways of defining that. What are the semantic properties and relations that we should be based on, and also there are different knowledge bases on fundamental conceptual geo concepts and entities and knowledge. This was a GI need to know body of knowledge. And if you need more information about how we use ontologies for semantic integration, this is one book that was written some years ago. And the last point I would like to make in the 5 minutes I've left is that the new cartographies are interactive, they are inclusive, they're ubiquitous, they're metaphorical, and they map almost everything, either geo information or non-geo information. And new cartographies touch upon a number of issues like spatialization and conceptual structures. They exploit the authoritative power of maps, and they help to have maps from everyone. And we move from personalized content to serving personalized maps. And we should also know that our objective maps are not that objective. So a few examples of this, there have been a number of thematic map engines developed, like we see here about history, some heat maps from Franken Place. We see from World Mapper cartograms about the earthquake risk. We also see here the coronavirus deaths in August, and in another cartogram that shows you where things were really bad. Of course, I noticed that there was a comment at the bottom, it's going away, it will go away, things will go away. That was by Donald Trump in the 5th of August. So we use semantics actually to help spatialization of text corpora. And this is another map, not like the old maps, that shows you 95 hub cities and which ones are more important and which ones associate to the other ones. So we use semantics to produce new types of maps. And my last example that you're also aware of is how we use sentiment analysis to produce different maps. This was about locations and environmental terms, and the sentiment, the emotion they cause to people, the polarity, whether it's negative, positive, or neutral, and the actual emotion, where it's anger, joy, sadness, happiness. And the diagram at the bottom is another map that connects cities that environmentally are happy locations. People are happy, or they're sad, or they feel bad, or they feel good. So I think I'm moving to the conclusions, and what I would keep from this is that everything is spatial. Location and spatial properties associated with ontological elements builds real knowledge. There is misconception about sharing common concepts, truth, and the world. And the semantic and ontological instruments are essential to information extraction, comparison, and integration, but also to validation, to help us find whether some information is really valid or it's fake. And the last one is that new cartographies are based on semantic spatialization, mapping concepts, sentiments, and moods, and they support human and machine interpretation. So that's all I had to say, Benedict. Thank you very much.
Thank you very much, Marinos. I think we have 5 minutes for the questions, so this is great. So there are questions in the chat. The first question was from France Nib, who asked. So you talk about the either spatial, what, and then at the end you say everything almost is spatial. But do you think they are also some specific characteristics you mentioned that are adapted also to non-geographical data. For instance, the fact that sometimes there is something people think it's the truth, but actually it's not the truth. It's only there is some authoritative characteristic or things like this.
Yeah. We're talking about Fran's question now. It is true that it works both ways. Actually, yesterday I read, I saw an interview that someone said something very interesting, that the actual text of from Homer about the Odyssey is more true, more real than visiting the actual place where things had to happen. So it's not a joke. It is true that text contains important information, but also some text gets information from spatial data, but depends on what we have and what it works definitely both ways. As with ontologies, ontologies help us semantically retrieving useful information, but when we elicit information from text, it helps us build better ontologies. So this is what I had to say about this question. I see another one from Simon Benedict, or you asked something in a
Yes.
specific case.
No, but you can ask. You can look at Simon question.
Yeah. Hi, Simon. Simon is wondering whether the role of core concepts is extracting geoconcepts from text. To what extent could then help extract geosemantics from text? Well, the core concepts are the ones that were derived and published, from from Santa Barbara and Werner Kuhn, if I'm not wrong. And well, they help us, grounding sometimes our information. I'm not saying that we can extract geoconcepts from text using them. We may, but I didn't try it. I tried with other core concepts. I saw a number of them after this one that maybe Simon knows more about this one. And to what extent could they help extract geosemantics? Yeah. Okay. So this is, Simon, what I had to say. Ontologies help us. I'm not sure whether the core concepts, I think they do, however. They help us extract geosemantics from text. At least our experiments show we can do that. Yeah. Any other question? Fran said if are only geographical data spatial or non-geographical data are true. Yes, they are. If we say that we're not saying that the only spatial information is spatial, okay? But we're saying that spatial information is spatial indeed. And it's cross-cutting. That's very important. If you see things spatially, it's a cross-cutting ability, helping people no matter what they do. So this is what I believe. So.
And also, I had a question on common sense knowledge.
Sorry, Benedict, you had a question?
Yes, I had a question, but I did not write it in the chat. It was on common sense knowledge.
Yes.
Could you maybe elaborate more on
the common sense?
Yeah, what would be the solution to support democratic debate and so on, considering there is no unique common sense knowledge about located entities, for instance?
Yeah, that's a very good question, and I don't know whether I have a good answer to this. It's a big issue. Definitely, we use common sense in our everyday life, and everyone's view of the world is very important. but it is important to know that these views are not the same. And we do not mean the same things using the same words or the same maps. So it's important to put them together and try to see where they're the same or they're different. And then we know that by the term pollution or by the term economic development, we may mean different things. So once we get into the essential properties of the things, how we define things, what are the things that define them, then we know whether we talk about the same thing or a different one. That's a short answer to your very good question, Benedict.
Okay. I'm not sure if Christoph is.
Yeah,
ready.
Benedict, he's here. You can hand over to Rob and Christoph.